Good evening, everybody. So thank you very much, Steve, for the great presentation. I have 3 questions. The first question is, you've made some pieces out of mild steel, the mixture of mild steel and spring steel. I thought, but when the mild steel deforms, that's what do you weld them on again with mild steel before putting them back into the original into the original form, or do you make a whole new piece?
Yeah, I think what I tend to do on those tools, it was right at the end, wasn't it? Can I skip to the end?
Yeah, with all the tools lying there were 2 with mild steel, I think.
Well, if I pick that one there, you can see that's welded there and there. When they break, which they do, I just weld them back on, clean the weld back and re-weld it.
But I mean, a little bit further into the demonstration, you've got your tools you use underneath the Powerhammer.
Yeah, okay.
Yeah, a little bit further.
Yeah.
Those. And there you have, this is made of one piece, out of one piece of spring steel, huh?
Yeah.
When I'm correct. But there were 2 others who were made of mild steel.
Yeah.
And those. You've got the far right one, and then the middle one, I believe. Those are mild steel that you said.
Yeah, that's mild steel, and that's just I think that's a piece of bit of 40mm round bar just sliced in half, and that's just welded on. That lasts a bit longer than that one, depending what you use. If you're using it under very hot steel, they last a lot longer, but they deform round this area here. They would flatten out, so you either can re-sand it with an angle grinder back to shape, or at some point you'd have to remake it, but that's just welded onto a piece of flat bar.
Okay.
That lasts pretty well. Mild steel, you could case harden it if you wanted to. That would give it extra life. But if you're working on a quite hot material, they've got a pretty good life, and they're expendable. They're expendable in many ways. This one here is a slightly larger version of this, but that's made out of a piece of tool steel, and that's one piece. But that's fast to make. Making something like that takes a lot longer. All these, where they're one piece, take longer to make. These you can fabricate very quickly. So it all depends what you're doing, really.
Yeah, I understand. Okay, thank you very much.
That's okay.
Then case hardened. That maybe I don't understand it in Flemish or in German, but what do you mean with case hardened?
Case hardening is a process where you heat you would heat the material. Let's say, for instance, let's go back to this. You would heat these to cherry red 900, and then you immerse them in a
oil.
No, it's not oil. It's a carbon-rich material. In the UK, we used to get a material called casenet, and I don't know the ingredients of it, but it's a carbon-rich material. You heat this tooling up to a dull red. You immerse it in the powder, cover it over, leave it soaking for a few minutes, lift it out, knock off the surplus, put it back in the fire, reheat it to a cherry red, and normally the surplus of that comes away. Brush it off, put it back in the case hardening powder, do that about 3 times, and then at a cherry red, you plunge it into cold water and do the old figure of 8 movement. So you get a faster quench, and that hardens it. It's probably half a thou or something like that into the surface of the material. What's on the market now, I think, comes from Germany. I should imagine
Yeah.
Anglia.
Angela sells some case hardening. What is it? No,
Patrick,
Angela sells this stuff.
wie heißt es dann in Deutsch? Was ist die Name dann in Deutsch?
This is a wonderful question. What's the name in German? I don't know right now.
Okay.
But I think the German term is Oberflächenhärtung.
Okay.
But they will, yeah, Anglia do keep.
Angela is selling stuff like a case hardening compound.
Yeah,
Okay, thank you very much.
if you put it into a search engine, case hardening
Pardon?
compound, it's something you'd find a couple of companies that come up.
Like
Okay.
an American product is cherry red. This I know I got last year when I was visiting Monica and Benjamin.
Yeah,
But Angela sells something for this.
Okay, thank you very much. And then I have one last question, Steve, if I may. When you make the tool here that you have on the picture now that you've drawn, eh? No, the one you had, no, the other one. Yes, this one. Do you first drill the hole in a square bar? That's how I would do it. Or do you make it with a Dremel or something in each piece?
no, you drill it through these 2 separate pieces, or with that piece inserted, I'd weld them together so they act as one piece, and then then I would drill through, well, almost through with the larger drill here. You can see my cursor. Go almost through. You leave about 3 mil this end, 3 or 4 mil, something like that, and then you drill that out to a larger diameter. I mean, it's a while since what you could do is pilot drill it to that diameter first, and then drill through with your larger drill till you come within a few millimeters of that end. And then this area here is then relieved with a die grinder or a Dremel or something that holds a rotary cutter, just so you can remove the excess material. You could do it with a file if you wanted to. It just takes a bit longer.
Okay. Thank you very much.
That's fine.
So just for everyone who is interested, I just posted the link. In German, it's Aufstreu-Härtepulver. What a crazy term. But it's sold like this. The link has been posted to the chat. For everyone who's in Europe, Angela is sending Europe wide. Yeah.
Thank you very much.
So I guess these were all the questions of you. And then there is one question from Jeff Boatman, and then Martin's iPad has been raising the hand. So I first read the Jeff Boatman. Are these tools typically useful for a fly press too? Also, is ProGain like Atlantic 33?
You'd have to tell me what Atlantic 33 does, how you harden it. I've not used Atlantic 33. This particular tool steel, as I said, was made by British Steel for the mining industry and is no longer made, unfortunately. But it was basically, you forged it to whatever shape you wanted, normally chisels or such like, or tools like this, heat the whole thing up to a cherry red, quench it, and that hardens it. no tempering or anything. And then say this end here, you would heat back to a dull red and then just let it cool. And that softens it, that normalizes it, leaving this area hard. I don't know whether Atlantic steel operates like that. This is not an air hardening steel. It's you have to quench it to harden it.
Okay, thank you. I know just a little bit about Atlantic 33 or Flutagon. I put a link in the chat also, but it is air hardening, I believe. So, and thank you, by the way, for your presentation. It's very insightful.
Thank you. Yeah, I tend not to use air hardening steels because they are very hard. And if you're making chisels, etc., it's not always easy letting the end down where you want to hit it. They can become too hard. That's what I found. And you have to have a particular hammer to use them so you don't bruise your decent hammer. But there we go. They are used by quite a few people. But basically, if you're forging mild steel, it's quite a soft material once it's hot. So I tend to try and steer away from too technical steels.
Yeah, this answers the second part of the question. Then there was the first. Are these typically useful for the fly press too, the tools you have been shown?
You could use these under a fly press. Just trying to think if I got a fly press picture. You could use them under a fly press. You would have to, but what you would do is, well, there's two things you could do. You could use that under a fly press, holding it with one hand and using the other hand to swing your press, but you'd have to fix your work down. So what you would normally use is you'd put a bar on the underside of that you would insert in the round hole of the press of the arbor. Let me see. Just trying to think where I can lay my hands quickly on a fly press photo. Yeah, you can see that this fly press here, you can see this tool here. Basically, that has a round stub welded onto that flat, which you can just see poking out here. This is quite a large press. Often, if you're familiar with the fly press, they're a smaller configuration, but they all have the hole up through here, which is normally about 1 inch stroke 25 mil, and you then weld that on to the base of whatever tool it is. So you could have it on the back of there or any one of these and use it on a fly press. Fly press it's another thing you could have a talk on its own. It's a hugely versatile tool, the fly press, and yeah, I use it quite a bit. Here I'm set up just straightening something, and I've got a piece of timber under there, a piece of softwood, because it offers a bit of resistance. And when you've got just a small modification to make to the bar, that resistance is enough, so you don't overbend it or over straighten it, so you've got to go back over it. You had a piece just here and a piece just here supporting it and a gap underneath. It's very easy to overbend stuff, so that's why I use a block of wood. You could use another soft material if you wanted to, heavy bit of rubber block or something that gives a bit of resistance. But yeah, does that answer the fly press question adequately?
Yes, thank you very much. Very helpful.
Yeah, I had a
Got this
question about the depth of your tenon, your dies on your tenon dies there. The chamfer at the end, does that not limit the length of the tenon then, or is that an optional thing, the taper there?
On the tenon tool,
Yeah, the two dies, the dies, yes. So that last part where it's reduced down, that's the shape of your drill bit end. And I'm wondering why, if that's necessary. I noticed some of your other tenons did not have that in the positive. And so does that not limit the depth of your tenon?
depth I'm reading as length of tenon. The length.
Yeah,
of,
so normally I just run it long through there, and then if I need to chamfer the end, I do that by hand on the anvil. And I thought if that's collared down like that, then that would limit the length of the tenon. I guess if you're doing repetitive tenons all exactly the same size, then that would be the way to go, obviously. But my material tends to go out, run long through the end.
But no, you can basically the length of your tenon would be governed by how much material you you marked on your bar. So let me I've got tenon. Let's think.
You had an image of completed tenons, and they were not chamfered on the end.
No, that's right. Let me just right. The tenon was. Where do I want to go forwards? Right. You can see that ridge there.
Yes.
That's where that tool cut in. Now, I think that was marked back about 20 mil. So if I mark that back 30 or 40 mil, I could still cut in there, but I'd have a lot more material to forge out. So it doesn't inhibit the length of your tenon. Now, let me just go back a bit more to that picture you were talking about.
So that's your first pass.
Yeah.
Before you go to the top and bottom tenon dies.
Yeah, that's it. So I could put that tool anywhere along here and I'd have a bigger stub sticking out the other end. That's just creating me a sharp shoulder that tool goes against. So what would happen if you had a lot of material on a longer tenon? It wouldn't affect it on this, but you'd have a lot more forging to do. If we go forward slightly.
Right.
You can see that there, that gives you a nice shoulder there. So the amount of material you've got here, you've got total control over that. If I'd have put that mark back here, I'd have had a lot more material to forge into my tenon. So often you find you normally have to trim them back to the exact length you want. The other ones that you saw were, if I go back, you can see you can see there, that's where I've cut them with a knife when it was in the square section. So that is still longer than I need. These are all just been roughly cut. So I will cut those back to the correct length, you know, later on in the job. You can see
so those ends, the ends of those two top and bottom dies, the end of your cross section in your dies is the last pass on a predetermined length of the tenon.
Yeah, if you're using a swaging tool, yeah, I mean, how much you mark before you forge your tenon will determine ultimately the length of the tenon. So you'll just, if you're working it between a swage, Was there a swage on here? Did I show a swaging operation? I think I did. Yeah, right. If you've got a lot of material, you'll find it'll be hanging out the back of your swage.
Yes.
So you'll have to pull this bar back through. So you'll be working it backwards and forwards in your swage. That's all you would be doing. Or you could make yourself a set of longer dies here. You could make them a lot longer if you wanted to. You can make that, you know, 60, 70 mil if you wanted to. But this is just gives a short tenon, and any surplus sticking out in the back, if I don't need it, I just cut it off. I normally work out roughly the amount of material I'm going to need to produce the tenon, and then you just cut it back. They don't come out exactly to length. You could get them to come out that way, I guess, but they've normally got to be cut at some point before you rivet the job up. So you just trim them to length then with a hacksaw or angle grinder or however you choose to cut them. Have I answered your question sufficiently?
Yes. Thank you.
Yeah, here has come in the meantime also the from Beth the comment that it's the other way, that this just butcher it first and then the tenon is formed with the second tool. But anyway, I think it got clear.
Yeah, that's the final process. That is a swage. Yeah, you butcher it and then forge the material out. If we go back, I guess you'll see it. Yeah, that's me just cutting off the surplus. You can see I forged that out from where it was butchered. Yeah, I'm just using that top and bottom tool there to draw the tenon out from where I butchered it. I roughly round it as well with that tool, so it sits in the swage easily, so there's not a lot of work for the swage to do. You do that by eye. Right, that's the first process, butchering it. And you can set that where you do that anywhere you like on the bar, depending on the length of the tenon or whatever detail you're forging the other side of it.
Yeah.
That's it, just forging that out now. You can do that under the Powerhammer. And I use that top and bottom tool. I'm just knocking the corners off a bit, keeping it square. Right, I use this tool instead because I can get tight up to this shoulder. You can do it using the faces of the tup here and here, but if you're not careful, you can easily catch this edge and it's difficult to get in dead tight. You can do it, but sometimes you don't, and it pulls that edge down, which is very annoying. So I tend to use these tools here just to get that in.
Yeah. Looks like some of the people in this chat have similar experience, me included.
Steve, can we have another look at that bolster plate that you made for opening up the eyes at the beginning of your video there? Because that was really, really clever.
Oh, I see. Yeah. Okay. Let me go. Oops. Right. It's not this bit, is it? It's just a bit further on, isn't it?
Yeah, it's after you've chiseled and then you're inserting that thin plate drift.
That tool there is just a bit of road drill. It's tough. I just forge it out, leave it to cool, and it's fine. It really takes the punishment. What this here?
Yes.
Let's go a bit further, and you can. Yeah, I made that specially for this job.
I suspected you had.
So that is a piece of spring. That plate is a piece of spring which I drew out. Hang on. You can see it here. Yeah, you can see it there.
Yeah,
I
really
made
nice.
that out of a bit of spring, and then it's got a rounded edge on that. Then I can drive that down into there to where I've split it, and it just obviously the inner faces of where I've cut, they're not dead flat, so this just acts as a solid piece to for them to be forged against. And also it spreads out sideways a little bit because you get a little bit of reduction on the width
Right. Really clever.
when you're cutting. Yeah.
Brilliant.
So yeah, that works well. Yeah, and I just knock that edge gets a bit burred where you're knocking it back through, but you just have to hit it with the old grinder. Yeah, that plate was made specially to do it. Yeah, it's
Fantastic. Thank you.
Yeah, that's nice.
Well, I just have to say the same. It's fantastic. Okay, then I would have a question. You had, beside this tool for butchering in, you had one which has 2 channels for this roping. How did you get the 2 channels side by side?
We mean this one here?
Yes, the lower, yes.
Yeah, basically, if you imagine that is all filled in, these are tack welded together, so they're effectively one block. And you see here, you can see the marking outlines there. You have to remember this edge all round here has been relieved. You can just see inside there the true diameter. This has been filed out. So I'd have marked that there and there. That's the center line. And in between the center of here and here, this about there, I'd have put a center punch mark here, 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 and here. Got it in the drill and drilled through. It was at 8 millimeters, 8 mil drill, and
So 8 millimeters would have been four holes, and then you chased it out to that shape.
Yeah, 4 holes, and that gives you the basic shape. Now, that would have been, that flashing there would have been right up here and but very thin. The holes almost touch, but not quite.
They almost touch. Okay, yeah.
Touch, not quite.
So am I to assume that in running the stock, you'd run it through the whole length in that shape and then turn it on 90 and run it through again?
That's it. Yeah, you'd start with I'd start with a 16 mil square and run it through. You won't get it all in one go. So when you put it through first time, you get this here, makes the groove in the bar here and here. Then you rotate it 90 and do the same again. And then you just keep rotating it until you've got and you'd be moving it backwards and forwards over your heat. If you've got a heat of approximately 10 inches, 8 inches, whatever your heat is, you'd run that backwards and forwards over it. But where the heat stops, you don't cut right in sharp, otherwise you'll get a step. So you always leave it so you can blend it in. So it will be less forged. If I was doing it on here, I'd come up here, but I wouldn't drive the tool right in. I'd leave it partially forged. So when I heated this area, I could then continue up, and then you'll get a smooth transition from one, over the length of your bar.
And you have to go the full length with that cut, and then you go 90 degrees and do the full length.
No, you would.
In other words, you've got the distortion lengthening happening with one pass, and of course, this is only the hot area, and then you rotate and do the opposite side. You can't do both sides or all four sides.
No, you can't. You have to do one side. Well, you start on one side, then rotate it. So if you had a 6-inch heat, let's say 150 mil, you'd run up your 150 on one, rotate, go back, rotate, go back, and looking at what you're doing, and then do it like that, and then move on to the next section. It's just when you move to your next section, you need to not fully forge the last where your heat ends on heat 1. When you come to the end of where heat 1 ends, you don't fully forge it, otherwise you'll get a step in that you won't be able to forge out. So you do it gradually. So you get a transition from from that form to the blank bar. I should have done a sample. I could have shown you easily with a sample. But yeah, it's pretty straightforward to do. What I would do before you could do is draw that out on a piece of paper or a piece of card, and it'd be self-explanatory then. If you draw it out on a piece of card, you'd see. And also in these areas here, you can file the profile. I might make that tool, do a pass, and think, well, I need to relieve these edges a bit more, or relieve these a bit more, so you don't get sharp cuts into the material. They normally take a little bit of time to get right, but the more you make them, you get a feel for it. You can see what needs to be done, but they're pretty straightforward to make. Then this would have been made and then case hardened, and they last a good time.
Well, thank you. At least my question has been thoroughly answered. Thank you. Looks like there are no further questions right now. There have been a couple of thank you notes from Paul. Thank you very much, Steve, for your very interesting presentation. Participants, thank you for the good questions. And Monica and Benjamin have been writing, thank you for the fabulous presentation, Steve. Really great stuff, very informative and clearly presented. I think the same. Thank you a lot. Another from Jeff Boatman. Thank you for sharing your time and knowledge. This was a very interesting presentation. 2 more announcements. For some time now, we have been asking for donations because this project has running costs, and it's a bit on top of this everything, and we would like to share at least the running costs with everyone who enjoys and participates in the Treff and gets something out of it. So I was advised to post the link where you can give the donations if you ever choose to. And no contribution is too small. You can contribute monthly, you can contribute one time, and even if you think it's only €5, it's €3, it's at least €3 or €5 more than 0, and it still helps. And the other announcement, we have a sponsor. as this Blacksmith Without Borders project, quite recently acquired, and it's a project I run with Kees Klaassen, who has already earlier given a Treff presentation how to beat life into your forging. That was the name of the Treff, and it made it also to the name of the project, or the name of the online classes we are running together, Kees and me. And yeah, if you're interested in this, the link will soon be also on the website. It's beatlifeintoyourforging.com. And yeah, it's one of the sponsors. So if you purchase an online course there, it shows to this Beat Life into Your Forging project that the sponsorship is worthwhile. So it's a double benefit you could get from there. On my behalf, thank you for your time and for your being here, and looking forward to see you again